Okay, so today we're going to work with linear models. So remember yesterday we were talking about the graphical models and how can we use the graphical models to predict things in the future, right? So most of the time when we collect data, we don't collect data that will make sense, that are a perfect line or that are a perfect graph, right? So sometimes we have to kind of put them on a graph and then try to find the best fit or the best fit and predict what's happening. So what we're going to talk about today specifically is linear models. So we see table, graphs, equations, right? You've seen them all. You've seen table values. You've seen equations, y equals to whatever the equation is. And we have seen graphs. So they are all examples of mathematical models. Now, what's special about the linear models? So linear models represent quantities that increase or decrease by a constant amount, okay? So that means, let's say if you are getting paid $15 an hour, right? So every hour you work, you're gonna get the same amount, 15, so that's a constant change.
Is a slope, right?
Yes, so the constant amount that represents the slope. So over equal intervals. Right? So the constant amount over equal intervals, we call that the slope. But we're going to talk a little bit more about slope. I have missed a point that I should write right here. So if you want to add this point. In a table of values, the first difference are constant. Are equal. That's what tells you that you have a linear relation, is when you do your first difference. We're going to do first difference and I'm going to show you how you do the first difference. But to be able to understand that this is a linear model, if you have a table of value, you must do the first difference. And if your first difference is equal, then you have a linear relation. How would the graph look like? Straight line, right? A graph is a straight line. So in a table of value, your first difference would be constant. On a graph, you'll have a straight line. And if you are looking at an equation, what would the equation look like?
Y equal mv.
Mx.
Mx.
Yeah. M
X
plus b.
Y.
Right? So your equation is going to look like this, where your degree is 1. Your highest degree is 1. So the degree on the x is 1. What's your slope? Your slope is represented by what letter?
M.
M. And B is
Y-intercept.
the y-intercept. Okay? So your equation is always going to look like this. Your equation is going to always look like, let's say, for example, y equals 2x plus 5. Right? This represents a linear relation. 2 represents your slope. 5 represents your y-intercept. And the rate of change is constant. It is the slope, and that's why it's constant. So you see that it's everything is around that slope, right? Around that rate of change that is constant. The first difference is constant. So let's look at how do you find the first difference. So we have a table of value here. This is your x value, and this is your y value, right? X, y. When you want to do the first difference, what do?
Y2, Y1.
That's right. So you're going to do y2 minus y1. So you're going to get negative 5. Now you're going to do y2 minus y1 again. So if you look at your first difference, here, what do you notice?
It's different, it's not the same.
It's not the same. Since your first difference is not the same, then you can make a conclusion that it is not linear. Okay? I do the first difference of the second table of values. So what I have here is I have time as my x and earning as my y, right? First difference is always y2 minus y1, okay? So you're always doing y2 minus y1. So 40 minus 0. 80 minus 40, and 120 minus 80.
The same, it's linear.
Right? My first difference is constant, right? Therefore, it's a linear equation. Now, something that I want you to always look at, not only when you're doing your first, like not only you do your first difference and you go and do your conclusion, you also have to look at your x value and make sure that your x value are increasing by the same increments, right? Because if they're not, then you can't do the y2 minus y1, okay? So you see how this is always going up by 5, right? Mm-hmm. Perfect. They're all like, you're going by the same interval, okay? In this case, you're going always by 1. So you're going by the same interval, okay? So you're comparing your y2 minus y1 with respect to the same interval, okay? So you always have to make sure that your x's are going up by the same amount.
There is a case that maybe do we go with this?
I will not be testing you, like I will not be giving you a case like that, because then you can't do the first difference. Let's say if you are making a table of value, you have to make sure that the x values that you pick have to be going up by the same increment. Like you can't go 0, 1, 10, 56, like you can't do that. You have to be picking numbers that are going up by the same amount.
In the same,
Right?
yeah.
So you can't be going x value, if you are making the table of value, right? You can't go like 0, 1, 10, 30,
Yeah.
right? You know what I mean?
Numbers
Because then
that-
you can't do the first difference. Does it make sense?
Yes.
Are you guys okay with this part?
Yes.
Okay? Now, oops. In this case, what am I looking at? A second. In these cases, the C and D. what am I looking at? Am I looking at a table of value? Am I looking at an equation? Or am I looking at a graph?
Table of value.
I'm looking at a graph, right? These are graphs,
Choose
right? So which one of these graphs is a linear function?
first one.
C. C is a linear function. How do you know it's a linear function? It's a straight line. Okay. How about the other one?
It's not linear.
It's not a straight line, right? It has a curve to it. So when you're looking at a graph, that's all what you're looking for. Now with E and F, what am I looking at? Graph, table of value, or equation?
Equation.
Equation. What did we say about the equation of a linear function?
The first one is linear.
The first one is linear
We
because
have mx plus b. We have slope and we have y interest. Yeah.
the important part is your degrees one, right? I mean, if you look at this right here, right? You think that it's a slope and y-intercept, but it is not, right? Because you have a square, okay? So the important part here is that your degree is 1. So let's write this. Degree 1, so it is linear. This one, degree 2, so it's not